So thanks, Mika, for inviting me, and thanks for everyone to join. I think you can see my slides now. So the way I have structured the talk on request from Mika is that I will give my first 15 minutes as an intro to AI and machine learning, and I'm not aware of how many of you have experience in that. So if you're already experienced in that, please excuse those 15 minutes. I will try to keep it more basic and understandable to wider audience. Then the next part, around 20 minutes, I will spend on giving some case studies. These are the work that we have done in Omdena, and also, of course, briefly present Omdena too. But the focus will be only on the case studies that we have worked on, some of the case studies. And then at the final 5 minutes, I will kind of come to the point is how can you guys potentially define an AI project and go ahead and work on those projects and build those solutions. So before I start, thought it's always a good idea to give a background about myself. As Mika said, so my background actually it's not 20, it's 12 actually. I mean, of course, some of the years I haven't been actively working in AI and machine learning. So although I started initially at 2002, that's 18 years ago. And I was mostly as an engineer, researcher. I published research papers on AI, on various topics on AI. So I was purely a tech person. And then did my master's in Cambridge. And after that, I had the phase of being an entrepreneur, built a few startups, including one was on machine learning-based startup. But my other startups were nothing to do with AI or machine learning. And 2017 is when I kind of took a break. I thought it's time for me to, not be anymore build companies. And I called myself an educator because I started enjoying writing. I started enjoying speaking. So I had the opportunity and the grace, right? Being able to invite it to over 30 countries, spoke in over 100 events. I wrote books. And I've also been, during the time, being a mentor of Google and SeedStar and many other organizations. So, and that's an interesting context where I will later on come back to this point of how my being a speaker and the writer and essentially traveling around the world and seeing different countries and cultures helped me build Omdena and kind of do what I'm doing now. But that's a bit later. So before that, as I said, let's go back to the point of intro to the AI and ML. And this is a common question that, well, now not so much, but a year ago, I would hear the most common question, and perhaps even now, many of you have the same question, that is AI all hype? And if not, what and where to use AI? And it's there are like technologies that are hyped. I will not name them, but there are many, and I consider a few of them to be really hyped. They are not in the state. So where is AI, and is it just kind of buzzword that everyone is using these days? And there is truth in that. I mean, there's a lot of organizations, a lot of companies are just using it as a buzzword, and there's no denial to that. But I would also say that there's a huge opportunity and value that we can create using AI and machine learning. So before I go into that, I thought of engaging the audience a bit, asking your questions. Feel free to answer them. So the first question that I would ask you guys, that you work in your own organization. So can you think of one process that you have encountered during your work which you think is inefficient and can be improved? And forget about AI, machine learning, anything. And I will just have this is a poll of yes and no. Let's see if people answer them. So I'll give like 10, 15 seconds to see how many people. Okay, it's interesting. I mean, there is not a single person who has said no. And that's always encouraging, right? So, okay, the one person who said no, I would be happy to hear that opinion. Maybe later on I will come back. Please remember, whoever answered that question no, maybe if I will have time in the end, I will come back and ask you that why do you think that you haven't encountered any process in your work that is inefficient? That means either you are working in a really efficient organization, or perhaps you haven't identified them. But I will be happy to check back. But as you said, 94% of the people have said it is inefficient. So now, if you think a bit more, like why is that? What is the cause of that inefficiency? And it may or may not be, but often you'll perhaps identify that some of the inefficiencies that you are thinking about in the process is because of the nature of human involvement. And humans are good at many things, and there is no denying that, but humans are not good at is analyzing data from multiple sources and which are incomplete, because we are not meant for doing that, and So that's how computers we use. Computers we use Excel, we use different things, but basically it's about analyzing data from multiple sources, which is incomplete, which perhaps you all will agree to that. Now, the next point is that, so that brings to this notion that we have called human error, and which is basically that it's defined as the error rate of any decision system or process that is human-centered. Now, not all human-centered decision-making has error also, and this is very important to realize that. For example, I give you this example of recognizing cats and dogs. I wrote an article called Stop Recognizing Cats and Dogs Using Machine Learning or using AI, because we are very good at doing that. I mean, if you show us a picture of an animal, we can very clearly spot the ears, the eyes, the shape, the patterns, and we know this is a cat, this is a dog, this is a human, this is a tree. We do that very well. In fact, machines are not that good at doing sometimes. What is a chair, what is it not? So human error in those kind of things, decision process is very easy and simple. Why? Because all the information that you have is in front of you. That's all that you need is a picture. And of course, the knowledge and things are in your background, but the picture has the knowledge, and you look at it, you analyze it, and kind of thing. So there is, you don't have to necessarily at that moment look at 50 pictures to know what is in that particular picture. But in other tasks, where you have a large data set, and you have to insight and analyze them to make a decision, and you have to store that, like, you know, that, like, so, and analyze. The question is analyzing. So that's where the human error is very high. By the way, feel free to ask me any questions or any comments that you might have it during the process. Let me just go back to the next slide. Okay. So naturally, my next question to you is, whoever said yes, not the one who said no, but whoever said yes, when you think about the inefficiency, and this is just an estimate, right? So what would be the case that you think that the case that you thought about inefficiency is the human error? What level of error that you are talking about? It might need a bit of thinking, because it doesn't come very intuitively, because I know the percentage and things like that, I understand that, but it just give a thought, just a quick thought. Is it like really very high, or is it something not so high? Okay, so I see that, you know, I don't know if you can see the results of the poll. I presume you can. Basically, what I see, that 20 to 40% have the most, and then 40 to 60%. Some have said 60 to 80%, and only 1% have said 80% plus, and 1% have said less than 20%. So, and that's completely valid. The highest number is 20 to 40%. So, and that's good. And just for you to think through, I mean, again, this is not mathematical exercise, but it's just for you guys to think, okay, there is an error, there's a human decision-making process, and there is some error in that, which is 20 to 40% could be quite low, high, you know, 50% plus is definitely quite high, kind of, you know, every second decision you will be making kind of potential to make mistake. And in 20 to 40, you're talking about every third or the fourth, basically kind of a mistake in that. So, right, and if these are critical decisions, well, you can assume that that could be quite problematic. And in cases where you're talking about 80%, and there are a lot of decisions where we take more than 80%, that's like really something that we should perhaps not do. And perhaps that gives you an idea about where am I going now, is that the key is to identify that kind of problems that you can, when you at your work, you think, oh, this isn't inefficient, and I think the human error in that is quite high. So can we do something to improve that process? And as a general notion, my claim is that you can pick up any sector in the world, healthcare, energy, banking, insurance, retail, any sector, and you will find inefficiencies and limitations in the existing process. Again, this is because of the inefficiency of human mind, as I said it. Now, I'm not, when I talk about human intelligence, and I'm not saying that humans are all bad. I mean, humans are very good at intuition, creativity, emotional intelligence. Absolutely, we have a lot of that. But as I said, we have something called fast thinking. You know, there's a great book on that. Like, and the author has given a lot of great examples of how we make decisions with fast thinking. We think very quickly without kind of analyzing them. I don't have the time to give those examples, but there are some really, really amazing examples there. or we cannot deal with large data, analyze slow, and we also have biases, right? So, for example, like a great example is recruitment process, and of course, you will say machines also have, but I will come back to that later. But recruitment process is one of the very biased environment, I would say. But there are many of that. So now all of that is great. Now the question is, what is AI? Where does that fit in, and why am I talking about all of these things? So again, AI, goes back 1950s. I think was the first time, and it has evolved. So the technology has evolved over the last 70 years. In 1950s people are trying to do, to some extent, what people are trying to do now. So initially, when I started my career in AI in 2002, I remember my interest was purely from mathematical point of view. So I loved mathematics. I was a computer scientist. I love computer science. And I was interested in, I love chess. So at that time, a lot of AI was about building a chess program or building a planning algorithm. So my first work was on soccer playing robots, how robots can play football. So AI has evolved a lot. So when we say about AI, we all don't have like one notion of AI. Some people create a human intelligence, right? Some people will say, oh, we want to replace human intelligence. We want to create machines which can think like human. Some people will take a more narrower focus of AI being, no, it is not about creating humans. It's about, things that our humans are not good at, building models that machines can do better than us. And I'm more in the second part of the story. I think that we don't understand our own intelligence that well. We don't understand what intuition is. I mean, I'm a very intuitive person, and we really do not understand what is intuition, let alone build a model that can, focus on building intuition. And again, I mean, if some of you are AI engineers or practitioners, you know that, okay, people will say there is a class of algorithms called reinforcement learning, which kinds of build intuition, but that's a different story. Not really. Human intuition is a very difficult to imitate. And also emotional intelligence, there's a lot of other things. So I think that our focus going forward should be, so I have written down some of those algorithms, but the one that has really captured the imagination of people around the world in the last 5 to 10 years is the machine learning part, not the, well, of course, there are people working the overall AI, and that has been there over the last 50, 60 years. People have been trying to do that. It was never mainstream. It became mainstream only during the machine learning algorithms. Now, why is that, and what exactly is machine learning? So machine learning is a class of algorithms of subpart of AI, where the basic goal is to learn patterns in data. That's as simple as that. Now, why that learning patterns is an interesting thing? Because there are patterns in everything that we do. If you think about your day-to-day life, what we buy, when we buy, what we like, what we don't like, even why a system fails, there is a pattern in everything. When we follow, most of the work that we do is following a pattern. So, and of course, consciously, we are not capturing that pattern. We are perhaps in our subconscious mind capturing some of the pattern. But if a machine can model that pattern, it can do things better than humans. It can predict what people are buying, what people are going to buy, and that could be scary. But of course, there are great use cases also. But I'm just saying that that's where the power of machine learning comes. But also, the machine learning traditionally needs data. And what has happened over the last 5 to 10 years, a generation of data. And that's why the machine learning algorithms became popular. It's not that these algorithms are very new. I mean, some of them are new, but these algorithms exist for at least 10, 15, 20 years. And what has happened that access to data or availability of data has made the algorithms much more powerful, and we can model those data to build the patterns in the data, and then use that patterns to predict, to forecast things. And that's the powerful of AI, the machine learning part. And that's why when we talk about in the beginning, when you remember, I was asking you about task and inefficiencies and human behavior. If you intuitively think, a lot of those tasks that you're talking about, the humans make decisions, but human make a like there is high human error, there are patterns also there. I would perhaps, and if you think that there will be patterns in there too. It's just that humans are not good at capturing those patterns when we make those decisions because of the limitations of our mind, as I said. So the goal there is, as I asked you, that can you think of thought, can you identify the patterns? This is a yes/no question, and maybe you will come up with them now, maybe you will not, but that's the basic idea. So I know 16 people actually answered yes to the first question. So I'm keen to see how many of you answer yes to this question. I will take 10 more seconds, and I will wait for that. Cool. I see that 13 of you have answered that question, and 9 of them, so 70% of you have said you have identified patterns. More of you have said you haven't. Again, I know that's something I would love to explore further, but those who haven't, I would say that it's possible that there are no patterns, or maybe you haven't identified them. But okay, so we'll, I mean, again, and I'll be happy to hear those cases maybe at the end if I have those opportunity that time. But it's good to see at least that 70% of you have identified those patterns, and that's what makes basically machine learning and AI powerful. So bringing that together, that what we are talking about, the machine intelligence has this, as I said, the patterns and analysis, but it has biases, and I will talk about that briefly. So what we should be really looking at if we are thinking about using AI is not to replace human. I mean, that's to me, it's a wrong notion. Maybe in some cases we can replace where the humans are not good at doing that. I mean, humans are doing the basic work of like, data entry or simple things. But in most cases, the decision-making process should be combined with human and machine intelligence, so that the strengths of both of them, there are strengths of humans and there are strengths of machines, and we both have to come together and build that next level of decision systems, so solutions that are going to do that. And that's the way I see human AI machine learning. And I did briefly talk about the biases here. Many people say that AI solutions have biases, and just to a quick comment on that, that bias is not in the systems. The bias is not in the algorithms. The bias is in the data. And now, why there is a bias in the data? Because humans have biases. So the bias that we have is reflected out in the data, which is then machines learn that pattern and then ends up having the bias. So it's important to realize that, because if we are really serious about removing the bias, then actually machines are the best way to go ahead also. Because once humans have the bias and we are aware of that bias that other humans might have, there are ways that we can unbias the data to make it more unbiased, to make it more transparent and ethical. And I'll talk about that again maybe in the later, but there are algorithms that are actually you can do that to debias the data. And that's why, in fact, when it's better if we think that there are biases. I'll give a very interesting example. Maybe many of you may know that Amazon built a recruitment solution to recruit engineers. And that machine was biased and sexist, basically. And everyone was like, wow, that's a sexist. But the reason was that it was being trained on data of past recruits that happened. And the past recruits were done by humans, mostly male engineers, and they were hiring mostly male engineers. So the bias that those male engineers have ended up reflected in the machine. The right way to build the solution would have been that you debias the data. There are, again, algorithms, and then build the solution. So I will say that machine intelligence is actually not biased. So we can remove the bias from that, and that humans have the bias, and we can actually make it as a strength that it's unbiased solution. So to finish this section, what I hope it gives you a good idea about thinking about it, where you can apply these algorithms. So what I suggest is that when we think about a problem or a solution where you think that you can build machine intelligence in, that is, first of all, think if it requires distributed data. It has multiple sources of data. It has quantifiable patterns, as I said. There are some patterns that you can quantify, not intuitive patterns, not like we think of something. There are high human error. Important to do that, because if we are solving a problem that has only 5% human error, I don't think that's the right problems to solve for AI at this point, because then the benchmark is very high. But if you're solving a problem that has 50%, 60% human error, it's very easy for the machine to be better than that. And then, of course, you have large amount of data, and that requires need of emotional intelligence, because that's why I think that you combine the humans and machines together. I've written all of these details in the book, and I will be, I mentioned that because I wrote this book, Creating Value with AI, which has very good reviews in Amazon. And I'll be, as part of this, I'll be happy to give some of you on request and access to that book, or give it for free. So the process that you guys have to go through is, first of all, select the right use case. The right use case, as I said, these are conditions. Identify the patterns through the human or domain expert, and then identify the data. And the data could be in your in-house, like in your company. Maybe you have to collect the data, or maybe it's public. And what I will give you some of the case studies, and there are a lot of those are publicly available data. And then you build the models, and you might have to overcome some of the data challenges, and then integrating your access. So that's the steps that basically, in a nutshell, is how you should go about building the solution. And as I said, this is the book I wrote. And I'm not trying to promote the book. I'm just saying that because it's kind of written high level, and I talk about some of these topics. And I would be happy to give you a free version of the book to the PDF at the end. If on request, I'll send them my email, and then feel free to ask me. So that ends the first part of the introduction to AI and ML. Next, before going to the nice case studies, Mika, maybe if there are any urgent questions, like one or two, I can take them up, and then I can move ahead to the next part.
Yeah, please go ahead if you have any questions. I was actually posting one question myself, so since I don't see anything else at the moment, I'm actually reading it here. That is it. You're talking about human error, but is it human efficiency? Because, for example, humans are very good at identifying photos, and we can do it accurately. So there's no error in that, but it just takes definitely a long time. Whereas the algorithms might be making a little bit more errors, but since they are so super fast, we're actually using them in large numbers of photos. Yeah. So I mean, the error is a benchmark. Efficiency is also, right? You can say that how long it takes for a human to make the decision, let's say, right? That if it takes a human 5 hours, although they have less error, is that a good process? That's also a valid point. I've highlighted the error in a way that's a more stronger use case, that we are making wrong decisions already, right? We are making certain, so we need to fix that. The time, if that's a concern, then yes, that is also a valid metric to look at, that the efficiency of human is very low, which takes 5, 10 hours, 15 hours. Maybe we want to improve that efficiency. That's also, yeah, absolutely. That's another metric that you can look at when you think about the cases. Okay. Otherwise, in the chat, we don't have any other questions at the moment. So please go ahead, Ru. Let's go to the case studies. Okay. Very interesting. So let's go ahead with the next case study. So, and these case studies are all like, through work that I have done part of the company. So this is not, I'm not taking from other parts of the world. So this is important to say that this is the work that we have done over the last 18 months. And I said that why I set up this company, I think it's important to give the background. So as I said, in 2018-19, I had this opportunity to travel around the world and speak. And what I realized when I was in all these different countries is that there is a huge power of the crowd, and there's a global talent pool. And that has happened primarily in the last few years because of the democratization of the knowledge. There are online courses out there, and you don't have to go to Stanford and MIT to get that courses. And people in anywhere in the world with the access, with the internet and a laptop or a PC, you have access to that. And that's great and that's powerful. So I thought that, okay, can I use the global pool and the talent out there? The second motivation that came to me was that, there's a huge potential about AI machine learning. And in the book, I talk about it also. And
and there are so many processes out there, but when we think about AI and machine learning, most of the people think about autonomous cars and robots and delivering pizzas and I don't know, like going to Mars and you know, like taking away jobs. That's a popular notion, which is very unfortunate. I would consider it very unfortunate because, I mean, that's again tapping into the top 1% of the population who needs an autonomous car. So, I mean, there are 8 billion people, like, you know, and of course you might say it will reduce the car accidents, but that's much down the line. I don't know when it will be. There are immediate problems that could be greatly benefited by using machine learning and improve lives of millions of people around the world. Why are we not really working on those? Perhaps because, you know, big companies are not fascinated by the problem, or the Silicon Valley is not interested in that kind of problem. But that's unfortunate, because I think there is a huge opportunity to solve those problems. And the third is that we live in a world which is so much driven by competition. Everywhere we are competing and we are trying to be the best and everything. But I think that if we as a society wants to solve the problems of the future or even the present, we have to collaborate. Everyone is smart in their own way. We come from different diverse backgrounds and cultures, so we need to come together, collaborate, and build those solutions. So these are the three things that I realized during my trips, and that made me build Omdena. And Omdena is exactly this platform where people from all over the world, currently 87, actually this is a bit updated, 87th country was South Korea. People from over 1,700 people from 87 countries have come together, collaborated till now on 36 such projects. And what we have seen and they come for 2 months, the 8 weeks time, and they build those solutions and they deliver that to the organizations. And we have seen that every single time it's a very efficient model, because these people are highly driven, they come together, they're focused at solving the problem. And this is also very ethical. Now, why is it ethical? And I mentioned a bit ago about biases, right? And I gave you this example about Amazon. One of the reasons that system was biased, because the engineers that built that system were male themselves. So of course the male, not that they had a bad intention, but they couldn't identify the biases in the data because they never experienced the bias themselves, because they are hired by Amazon, so they got hired, so they never experienced the bias. What would have happened if they had 1 or 2 people who were females, or who were actually experienced the bias during their career of not being hired? They would have immediately told Amazon that, hey, you need to take into account that bias in the data, because I know that's out there. So that's why the way to build efficient solutions, ethical solutions, is to get a diversity opinion, to involve people from different backgrounds and cultures, gender and everything, so that they can tell you that, and they're together building the solution, and that will make the solution much more ethical. So that's the way to, and that's what we have seen also. So that's the platform that we had built. And I'm going to give you examples of, out of this 36, I will give you a few of those different groups of work that we have done. So let's say, first example, I'll talk about policymaking, that how AI and let's just machine learning, I use the word machine learning in this case, can help policymakers make decisions. So this was an example of, in Nigeria, there was an NGO that came to us and said, they often, when they are promoting about solar power in Nigeria, many politicians think that they don't need solar power. The discussion is like an opinion-driven discussion, and that's what most decision-making process in like governments are, very driven by opinions rather than actually data-driven. So they say, can we build a solution that can help us to put our case in front of policymakers that, hey, look, that's why we need solar energy in Nigeria. So to do that, what we did was the community came together, many people from Africa, and they mapped the Nigeria into they built multiple maps of it. The first one in the left, you can see, this is a map of how Nigeria looks at night. So you see the dark and the bright parts are the places which has light at night, and the dark are ones which are, so this in the lower bottom you see it's a lot of lights, but when you go to in the top, there's hardly much lights. So it's how Nigeria looks at night. And the green and the red are population density. So just by looking at this map, you can immediately see that there are parts of Nigeria which are highly dense, like the red, and dark at night. So that's the first analysis we did. And the second analysis on the right bottom, you can see that this is a national grid, how the electric grid looks like. Again, collecting the data and things were challenges. It's not like this data is available somewhere there. So that's where we had to be a very innovative ways, but we managed to build that map. And you can see that what we had to do is identify clusters where there are 4,000 people, which are without electricity, means that are dark at night. 4,000 people of areas and that is more than 15 kilometers from the grid. So even if the government says, okay, we will improve our coal power because we have a lot of coal, these people will still not get the electricity because they are not in the grid. And that's how we built something called a demand heat map. And then at the end, this is an interactive map actually, and I don't know if the link is here. If not, I can send it if someone is interested. This is an interactive map where you can zoom in, zoom out. You can see the clusters. You see the number 19, 18, and we divided Nigeria into multiple segments, and each cluster you can go in and see those exact areas which require solar power and which doesn't. So it will be, and if you can show this to any policymaker, they will be like, wow, okay, I understand now. Why do we and where do we need solar power? And actually, the NGO is now using this map to show to the policymakers and working on that. So that's one example. I think I had another example. Let me show, because I think there was okay, maybe I'll come back to that. That example I put in somewhere else. But anyway, that's one of the examples. There are many other examples that are. We actually also worked on COVID, which I didn't give an example, where we showed how domestic violence and lockdown had an effect. And we clearly saw through the map that the moment there was a lower in mobility, that means lockdowns, there was a huge increase in domestic violence cases, which means that people are searching for domestic violence in Google. And then we started analyzing Twitter, Google, newspaper articles, and then we analyzed what causes domestic violence. Now, this is again very important because policymakers, perhaps many countries, did not take into account of the effects of lockdowns in those countries, specifically on the vulnerable population, women, children, older people. And had they known that, okay, the lockdowns has these kind of side effects, maybe many of them would have decided otherwise. Again, we built that model, and that example is not here, but another example that came to my mind is how policymaking can be benefited by using such kind of systems. The second example is disaster relief, right? How can we use machine learning AI in disaster relief? And this is the work we did with World Food Program. And the problem statement is very simple, that when a disaster strikes, World Food Program sends them that area lots of materials, right? So food items as well as non-food items, they send everything. How many people are affected? So they need to know that how much to send. Currently, it's that decision is very inefficiently done. And they said, okay, can we use previous records of the learning that we had, that when category 3 or category 4 cyclone hits or some in those countries, how many people got affected? What areas got affected? What is the population of those areas? So based on that, taking into account the category of a cyclone, the area that it could affect, the population in that area, and the density of the population. And in the past, how much food was sent or non-food items were sent. Based on all of that, analyzing all of that, we basically build a tool. And this article, you feel free to read this in Crisis. The link is in the below. I tried to give the references as much as I can, and if anyone wants to know more about them, I'll send the links also later on. So there, we kind of build a model that they can use for example, knowing disaster response during cyclones. Another work that we did was on disaster relief was in Istanbul. It was with Impact Hub, and one of the concerns that they said that during Istanbul is very densely populated, as you might know, and also there is a high risk of earthquakes. And they said that it's not predicting earthquake, that many companies are trying to do, but which I think may not be quite far away. But they said that the first concern of people after an earthquake hits is, how can I reach safely to my family or to my home or to another point, right? Could be to pick up my child, whatever. My first concern after earthquake is, I'm safe. I want to reach to my loved ones. And in that case, we said, okay, can we build an algorithm for that that could tell people that, okay, how to reach to your nearest safe, to the safe place that you want to go, not a safe zone, but I'm talking about an address that you want to go and how to go there. What is the best route to go there? So we took the most, to analyze that, we took the most densely populated district of Istanbul, I think it's Fatih. And what we did was we realized, and through the community, we realized that the roads that are most likely to be open are the roads which have the widest or which have most open areas, because in case, you know, earthquake, if buildings fall, the roads which will be open will be the ones which are narrow roads will be most likely closed. So and we had no way to collect the data about width of the road. So what we did is we analyzed satellite images. We looked at the building tops and we identified the rooftops of buildings, as you can see here. And then we built something called the heat map, which kind of gives how areas of which are open, like the yellow ones you can see are the more open ones. And through that, we build an algorithm which is passes through the less risky areas, which means more widely open areas. And in this algorithm, the benefit was also that if you see that in this picture, there are places like, you know, green area. And these green area would be also open, because, you know, maybe it will not be counted as the width of the road if we are just counting the width of the road, but we are taking into account all the open areas, including, you know, green areas. So that is much more accurate analysis of the algorithm. And if you look at this output, so let's say this is the from, and the person has to go to the to, and this is, I think, the blue line gives you what Google gives, the path, which is often the shortest path. And the yellow one is the one which was given by our algorithm. And as you can see, that it was bypassing through a lot of dense areas. So that's one of the work we did. Another example that I want to go into is case studies on prediction. So this was work we did in Chicago with an NGO, and which was also working with FBI. And they said that gangs are, you know, as many of you might know, the gang violence in Chicago. And they said gangs are actually a lot of time threatening and abusing each other through Twitter, but they use their own language. They don't use, you know, natural language English. So we had to first just say that, can we analyze what gangs are talking? So that was the initial requirement, that can we analyze what gangs are talking? So we built a system that was, you know, looking at those different symbols and the words, and kind of deciphering the gang language. But then the community said, can we actually go further and predict gang violence? And they said, okay, once we see that people are, you know, the mention of gun is more like not just gun, but also they're using symbol like gun, or you can see they have used like a weapon or a knife. So it was not just mention of gun, but in a threatening tweet, that if there is an actual correlation between a threatening tweet and crimes happening on the ground. And when we analyzed the same day, we saw that there was almost no correlation. But with shift, 1 day shift and 2 day shift, we saw there was a correlation. That means that what is happening, then the gangs are actually using Twitter to threat each other. And then in 2 days' time, actual violence is happening, which is very useful, because now you can predict by just analyzing Twitter that, in 2 days' time, there is most likely to be a more high violence. And not only that, but we were able to predict the increase in violence, but also that who could cause the violence, because we did a network analysis, and again, gangs are threatening to each other, right? So one gang is threatening to another gang. So we kind of also get to know not the person, but the gang, which gang is threatening which gang. So by that knowledge, you can also predict that where that violence would be, because gangs often act in their locality. So you would know that, okay, in these areas, there is going to be a crime in 2 days, kind of thing. So you can actually use machine to predict violence. Something similar we did also in Somalia, where the goal was to predict conflicts in Somalia. And to do that, what we worked with UNHCR, and what we wanted to do is that if there is a correlation between the human experts, they said, we think there is some correlation between conflicts and climate anomalies, like droughts, but we don't know exactly where is it, and can we model that? So we used there's something called through satellite images. We can model the vegetation index, which identifies how fertile area is. So over the last, I think like 10, 15 years, we modeled the vegetation index, as you can see in Somalia. 2005 was highly fertile, and then there was an area between 2012, 13, 14, it became less and less and less fertile. So there was more and more droughts happening. And then we saw, and then this was just overall Somalia. So we took one district of Somalia instead of the whole country. We took one of the areas, regions of Somalia, and what we tried to model was basically where there was increase in conflicts at a certain point and then decrease in conflicts. And then we see that, and this graph that you can see, that the red bar represent the conflicts, deaths, and the flow is the one which is represents the vegetation index. So as you can see, the vegetation index, whenever there is high, it has a much low conflicts and deaths in conflicts, as you can see in the right side of that. While in the left-hand side, when the vegetation index is low, not immediately, but within a certain time, there's an increase in deaths. Now, what does it mean? As you can understand, intuitively makes sense, because if the lands are fertile, people are staying in their neighborhoods, and there is no conflicts, and often conflicts might happen because of displacements. And whenever there's a lack of vegetation index, there's a displacement happening and then causing conflicts. Now, that was, of course, this was a proof, but also we could model that. So we can, in fact, also predict that if there is a drought coming, then we know in 3 months' time there will be an increase in conflicts. And in fact, we can even model the migration patterns of people. We haven't done that in this project, but we actually might try to model that in another context. So again, you can model that. So you can predict things. Another category is the prevention. How can we prevent? So of course, prediction and prevention are part of the same thing. Like if you can predict, you can prevent too. But I wanted to give you one additional example of prevention was in forest fire. We worked in Brazil, and the idea was to identify smoke, not fire, because fire is perhaps too late. Identify the smoke, and we did that quite well, because it was not an easy challenge. Because as you can see, there are these pictures where some of the pictures have clouds, and for a machine, it might be difficult to differentiate between a cloud and a smoke. And this is required because these cameras are running 24/7. There are cameras installed in remote parts of Brazil, including this was not in forest, but this was in the farmlands. So that's why the machine was required. Here is a great example of efficiency, because you cannot have a human. Human may be very good at doing this. Like that was a question that Mika asked. So just that I can connect that humans are very good at identifying forest fire, but they are not good at sitting 24/7 and checking it all the time. But here, the machine was able to do that. So that's what we had built. Something similar we did also in sexual harassment in India. Again, I will not go into much details, but there was this NGO. They came up with they had a lot of data of sexual harassment cases in India, with basically women reporting about sexual harassment to the app that they had built. They had around 15,000 data points in India. The largest amount of data, and this is often the women reporting, not because they don't want to go to the police, because that's another case that they want to avoid, but they want to report so that other women can benefit. And we saw that there is even patterns in certain types of sexual harassment at certain time of the day. So seems stalking happens a lot in the evenings. Sexual assault sometimes happens early in the morning, and this is you can again make sense. Like these are the peak hours of office hours. Like people are in the trains or in that, and that's where sexual assault. Groping actually also. So there are these patterns in everything. It's interesting to see that there are, and in fact, certain parts of the city we saw that there was a high sexual harassment. So it's not that it just happens randomly. Again, we think it might happen just anywhere, anytime, but it seems that it doesn't. It happens certain parts of the city, certain times there's a high sexual harassment cases, and that has to do with many things. That has to do with density, how many people are out there, or that has to do with the lighting of the area. The urban planning has a huge role. We saw that in two stations in Mumbai, which are equally crowded, there was almost no harassment reportings, while in two other stations there was a lot of cases. And that happened, I was told, because of the urban planning of those stations. Anyhow, so we mapped that heat map in the time. And what we wanted to build is an algorithm for planning, that when someone reports sexual harassment, the first thing that comes to the mind, as like in the earthquake, is how can I reach to a safe place? And in this case, the safe place would be perhaps a police station or a hospital or a metro station. So we kind of, and then, but the Google might show that person that go from this route, but that route may not be the safest route. So we mapped the heat maps or the past records, the timing, and then we build a algorithm, and they are actually integrating that in the app. And the final use case that I will be talking about is increasing inefficiencies, that you can again increase inefficiencies in again, many of those in the past cases were also increasing inefficiency, but this is an example which is, for example, which is quite interesting. We worked with World Resource Institute, and many of you know that there's this concept of collecting census data, and in this case in India, collect census data every 10 years. Why is that important? That the governments actually make their policies around the census data. So this is an example which I also wanted to give part of the government policy making. The government policies are often derived from the census data, but imagine in 2019, the government is making a policy, or 18, the census is done every 10 years. So the last time it was done is 2011, and it will be done in 2021. So government is relying on data from 2011 to build the policy in 2018. That's like, it's like 7 years is a long time to change things. So, and the census governments have used different categories, like the fuel they use, the water, the raw material, the light. So that's how they collect the data. And our challenge was, the World Resource Institute came to us and said, can we, instead of governments actually doing this door-to-door survey, can we use satellite images to build that same kind of model about economic well-being of people through just analyzing satellite images? So we used, again, I will not go in details, but the simple NDVI, NDBI, different bands, RGB, we use satellite images. And now that makes sense, you will think, because the areas people live represent the well-being of there. So the type of roof they have, the type of roads they have, the type of vegetation they have in their neighborhood, whether they have light at night or not. So that all that information, you can also get what you could get from doing a survey like that, because it's end up being telling the economic well-being. And we build a model, and this is the output of the model. And what we saw, that our model prediction is 70% accurate, which is not really 90. We are trying to improve the model, but this was the work we did in India, and which is very encouraging, that now the governments don't have to go in 10 years, spend millions of dollars to do this exercise of survey. They can just, with a click of a button, and just know the well-being of people. And they can do that every month, or as soon as the satellite data is available, which could be even every week. So that's a great, hugely development. I will skip this example because I don't think that's maybe that relevant. This was a work we did in Singapore, rooftop analysis for solar adoption. So I think that, overall, I gave you these examples. We're quite some time. So I think that the key here, you guys would understand that we have worked with governments, startups, big NGOs. So we worked with a lot of organizations, and in 18 months. I'll encourage you guys to go to the project page and the blog, where you can see all the projects we have done. Again, I don't have the time, so I only want a few of those. There are 36 projects, some of them ongoing. They will be starting in the next few weeks. Every week, we are starting one challenge now. And of course, you can also read the blog. Now, having all of that achieved, you guys will think, okay, what exactly, we are building these solutions in such a quick fashion. How is it possible? And as I said in the beginning, that it's the people. The key is the people from all over the world coming together, collaborating and building the solutions. And then, of course, we have built some processes, some tools, and knowledge base. And I want to stress on the people side here, because we are a really diverse group of people who come together and build the solution. Every challenge, normally, there are 40% women, age group is 17 to 65, all the continents are represented. And that creates this huge, quick way, in a very fast way, within 2 months, 8 weeks time, we build things, ethical, efficient way of building solution, which I know one of the organizations that has worked with us has said, for 2 years, they were trying to work something with Google, and they did what we did in 2 months was more than what Google could do in 2 years, actually. And of course, the processes, I will not go in details, but we make sure the processes that we have in-house are very ethical, and the development works in a very bottom-up environment. And then again, the partnership with tools and the infrastructure that we have built. So it's not just bring people together. So there's a whole ecosystem that we have built that makes sure that these works is being done. This is a comment that actually I got, someone wrote yesterday, and I just thought of putting it down. That what happens in Omdena is pure magic. The approach is simple: bring together a number of highly motivated professionals with diverse backgrounds and knowledge levels to get things done. It is truly rewarding experience that allows giving something back with sharpening your ML skills and help others sharpen theirs. And that's what, in essence, perhaps what makes people come together and do this thing. So before I end this section, I have realized that I've worked with 30+ projects in the last 18 months, NGOs, many of the big ones and also small ones, and everyone have to go through this journey of becoming AI enabled. And I think that it's time that all NGOs have to reinvent themselves and become AI enabled. The steps start with discovering, as we did in the first section of the talk, identify the problem. It's very important to identify the problem. Then build a proof of concept. That's what we did many, and then you build a product out of it, and then the final is capacity building, which I think is also very important, that organizations have to in-house upskill themselves so that they can come to the new era, which is, I think, is absolutely important going forward in the next years. So that finishes this section. Before I go, and the next section is only 5 minutes. How do you define and how can potentially work with Omdena if you guys are interested? So before I go, shall I take up questions, or just go ahead and finish the talk?
Yeah, let's take a question here because we have one. So Emma, would you like to ask, just open the mic and video and go ahead with your question, if you like, or of course I can read it as well. But
hi, Mika. I'm driving a car, so I'm not going to open my video, but I can ask the question like this, if you can hear me.
Yeah.
Yeah, so I just wanted to ask, so there are cases where when we use AI, it's built on existing data sets from, let's say, from decades. And the example that I used in my question was when banks and financial institutions use AI to make loan decisions, and the AI is built on existing data from decades of making loan decisions, but a lot of that data is biased, and it's based on biased and unequitable processes that are discriminatory, and there could be racial discrimination or regional discrimination or income discrimination, and that is what the AI is built on. And then when the AI is making those decisions, it's replicating those same biases. So when we are using data sets and data from longer periods of time, what are the ways that that can be mitigated so that we can still utilize AI for the efficiency and kind of take out the human inefficiency from the process, but at the same time make sure that we're not replicating and repeating the same biases and discriminations that have been happening for decades before?
Yeah, thanks for asking this question. And you specifically gave an example of banks. Actually, I work with a lot of banks, and I have advised many of them, and that actually quite falls to the next slide what I had. But how do you define the AI project? And one of the mistakes that almost every organization does when they think about AI is that they start with the data. And I always say, do not start with what they do is say, let's look what data I have and let's see what I can build on that data. That's the standard notion with every single organization, or not every, a lot of organizations that have come, and then they fall into that trap. Because once we are looking at the data, we are not taking into account what problem are we trying to solve. We are not really thinking at a higher level. So I will first of all argue that that happens, what you are saying, primarily because many organizations start just say, okay, this is the data I have, what can I build on top of the data? So they don't even come to the thinking processes. Oh, maybe the data has biases, maybe the data doesn't, because they're not thinking to the problem solving hat, thinking to the data solving part. That's the part one. The second part of that is if you start with, let's say, the problem solving, and then you say, okay, how can I deconstruct the problem? And then you think what data is out there, not only the data that I have, what data is out there. And then the question comes, there would be data that will be biased. Now, how do you know what bias is there? The way to do that is, that's why I said that what Omdena does is way more powerful, because you do have to involve multiple stakeholders to build a solution. So if by design, if it's only few engineers, sitting in a room and building a solution, most likely in 90% of the cases, I would say there will be bias because they have no understanding of what biases could be in the data because they don't face the problems that they're experiencing it. So that's why for Omdena, when we build something, we say we always have to involve people who have experienced the problem, who have a motivation that kind of not extrinsic, but also intrinsic motivation to solve that problem. So the way to debias is involve them, and then they will identify those biases. They'll say, okay, this data might have these are the potential biases that they have. And once you experience that, then there are standard algorithms and there are processes to debias the data. You can equate the data. For example, in the case of hiring process, what would have happened? Standard would have been, let's say, if they had a female engineer who was not hired by Amazon, let's say, she would have perhaps said that, look, I think there's bias in the data that you are using to hire. Then the next step is to when they are training the model, the data that you're using, you also take into account the data of the people that were hired, let's say females and males, and make them equal to train the model. So you're not oversampling one aspect of the data to build the model. So that knowledge, so the technical solution to that is very easy. It's actually very easy technical solution. The problem comes not because of lack of technology. The problem comes because lack of design thinking. They don't really know, the engineers know that there is a bias in the data. And that happens because of these two reasons. Either they start from the data point, they say, let's see what I can build through the data. Then of course you are not taking into account the overall problem. And the second is not involving all the stakeholders and involving a more diverse group of people. And in fact, it's a very good question also you asked, because if you guys know, 87% of AI solutions fail. 87%. Now, imagine a company spending millions of dollars, so much of money, and 87% of something fails. That's like ridiculous. And they don't fail because of technology. It's not that their engineers are stupid that they cannot build a solution. It fails because of the last stage, which is adoption. It mostly fails because of the adoption. And that happens because of exactly the unethical, not involving the stakeholders, not knowing how people use it, not putting an understanding of the users. And that's where all this solution, it fails. So I hope that answered your question to some extent.
Yes, thank you. Thanks.
So, and as I said, that falls into the next step of step one. So if you are thinking about building it, don't start with the data, really do not. That will bring a lot of problems. Start with the problem and an efficient process. Think, and then think the next step would be, as I said, the first step is discover the problem. And then the next is identify the data. And when you look at identifying data, I actually say not just identifying data in-house. Think there could be a ton of data outside. What are those data? What are those data that I could get to debias the data that I might have? Then select a model and minimum concept. Of course, I made it a very quick step. But the stage that you are in, I think the first step starts with the discovery, and then, of course, knowing the thinking through the data. And that's where Omdena as a platform works, at least works very well, because we bring this diverse group of people to help to identify the data. Most of the work that we do is often with data that is out there, openly available data, or even data that is kind of hidden in a way, which is not obviously there, that people cannot find. So I think that that brings to the end of this talk. And one of the things that during our conversation with Mika in the Fingo team, they said that we would like to give access Omdena platform with organizations that are part of Fingo team. So if you are interested in that, so I will first share that Fingo team will share a document with 3 simple questions that if you are interested, you can answer them, and that would help us to know, okay, that's a viable solution. Many of you who have said yes, and people who have said no to those initial questions that they cannot find a pattern, I'll be happy to hear those. So feel free to answer those questions or even reach out. We'll also be happy to share the book of my copy for free in a PDF version. The spelling of understand is wrong, I'm sorry. And then I also offered specifically for this talk is that if you want to discuss some of those questions, like where you couldn't find the pattern, or someone who said there is no inefficiency, I will be happy to hear your case. So there is a link to which is office hours. So I have put like 3 hours a week. I'm happy to hear your cases and see if that would help. So that brings to the end of my talk. Feel free to connect with me, and I will happy to answer your questions, and Mika, take it over from here.
Thanks very much, Ru. That was an excellent introduction and lots of very practical examples how AI has been used in international development. I think that's the key where a lot of the participants from NGOs are looking at what's the value in our work